Okay, so for 11-1, there are two sets of notes, so make sure you write down both sets. I'm going to start off with the first one, just in general, circles and arcs. So chapters 11 and 12 are about circles, and so we just need some basic information about circles. So to start off, we have circles are 360 degrees, and they are named by their center. So we would do a little circle with a dot, and then so that way it doesn't look like an O, and we would name it circle P because the center is P. So that's what I could name this circle right here. So next up we have diameter. Okay, diameter is a segment that goes across the whole circle through the center. It's double the radius, and we use D to define it. Okay, so our radius, let's double it. Okay. Now, what is a radius? It's a segment from the center to the edge of a circle. Some people will just say it's half the diameter, which is true, but specifically to name it without talking about the diameter, it is from the center to any edge, and the radius is the same all the way around. Okay. So those are basic things about circles you should really already know from middle school math. What's coming next is a little bit different. So central angle is an angle whose vertex is the center of the circle. That makes sense. P is the center of the circle, so angle APC, we have the little angle thing here, is a central angle, okay? Now, for circumference, it's the distance around the circle. There's two different ways to write the circumference. 2 pi r, you may remember it that way, and that's how it's written on my poster, or just pi times the diameter, because we know the diameter is 2 times the radius, okay? Now, we could either leave this in terms of pi, or we can put it into the calculator and actually figure out what this equals. Next up is we have an arc. So an arc is part of a circle or curve. So in order to talk about this, there's 3 different types of arcs. Remember, there's 3 different types of arcs. We have a semicircle, which is half of a circle. We have a minor arc and a major arc, okay? So a semicircle is half a circle. We have to name it by 3 points. So on this circle I have right here, a semicircle, I have to name it by 3 points. 2 points I want to do, so I can't just say A, B. And whenever I'm naming an arc, I have to use the little arc symbol, and I have to go around the outside of the circle. That should be telling you. So like an angle, you should be forming an angle. An arc, you should be going around the outside of the circle. So I should go ACB. I don't go ACB. No, I go ACB. Now, a minor arc is smaller than a semicircle, and it's named by 2 points. Okay, so 2 points, I could say AC or BC or CB, like that's the same one. CB and BC, that's the same minor arc. We wouldn't want to say AB. That's actually not anything. It's technically half a circle, but it's not using 3 points, so we can't name it that way. And then last but not least, a major arc. It's larger than a semicircle, and we name it by 3 points. The reason why we have to name it by 3 points is because if I just say AC, we'll go the short way. But if I say ABC, we go the long way, and we see it's bigger than a semicircle. Notice I'm also not going ABC. Okay, that's because it's an arc. I have to go around the outside of the circle. And it could be any point in between them. So if there was another point D here, I could name this a DC, okay? And that would be totally acceptable. Or ABC, or CBA. That's all the same ways to name this major arc, okay? I do want to talk about circumference one more time, about leaving it in terms of pi. Your answer, let's say we have a circle with a radius of 4, okay? 4 centimeters. And then, so that would give us a diameter of 8. And so our circumference, I can just write it as 2 pi r. 2 times 4 is 8. 8 pi centimeters. Don't forget to include your units, okay? Or I could put that in the calculator and do 8 times pi, which, let me just grab my phone. I don't care if you guys use 3.14 or pi to do this, but we would say C is approximately 25.12 centimeters, okay? So this is in terms of pi. In terms of pi. And this one is rounded. Okay, so read the question. If it says in terms of pi, leave it in terms of pi. If it says rounded, round it. Okay. So that is just the basics about circles, arcs, and circumference. Okay. Now we're going to talk about arc measure and arc length. Now these are two different concepts, and it's very important that you understand them. Arc measure is the measure of a minor arc, and it's equal to the measure of its corresponding central angle. So we just learned that a central angle is any angle where the vertex, the pointy part, is the center of the circle. So APC is a central angle. Now this just said that the arc measure is the same as the central angle. Okay? So let's see that. Arc AB, well, the central angle is 50 degrees. So arc AB must be 50 degrees. Then it says a major arc is 360 minus the minor arc. So let's think about that. Arc ACB, the major arc, is 360 minus that 50 degrees. So 360 minus 50 gets me 310 for this major arc. So remember, whole circles are 360. I want everything except for this red part, so I do 360 minus 50. And then a semicircle are always 180. So ABD or even ACD, those both equal 180. Okay, that's very important. And last but not least, to find DB, well, we know straight lines equal 180. So if this straight line equals 180, if this semicircle equals 180, we can even cover it. I can do 180 minus 50 to get what DB is. Okay? And that's a minor arc, so it's going to be less than 180. Okay? So that's what arc measure is. It's pretty simple. It's just based off of the central angle. Okay? So just be on the lookout for it. Don't forget about vertical angles as well. So like if I had another straight line right here, this one would also be 50. Now, arc length. Arc length is different than arc measure, so you have to read the question carefully. Is it asking for arc measure or arc length? Measure is in degrees. Length is in units, inches, centimeters, feet, whatever it may be. Okay? So this is like the angles of a quadrilateral, and this is like the sides. Except for in a circle, it's all together. Okay? So angles, sides. But circle doesn't really have sides. So we talk about arc length, different than arc measure. So we take the measure of the arc over 360. We want to see what portion of the circle we have times the circumference. And we already talked about circumference is just 2 pi r. Now you're like, but what is r? Well, in this circle, my r is 3 inches. We know that's the radius because it has the inches attached to it. We know this is an angle measure because it has degrees attached to it. So make sure you notice the difference between those. I would never say that this angle is 3. I would never say that this radius is 50. Okay, those are two very different things. So notice the difference between those. So to find the length of arc AB, I would take the measure of arc AB, which is 50, over 360 times the circumference. And remember, I could always just put any number over 1, right? So my circumference, 2 pi r, 3 times 2 is 6 times pi. I'm going to leave it in terms of pi. Always leave it in terms of pi unless it says to round. So I want 50 over 360 times 6 pi. Well, I have to reduce that fraction. Well, actually, I multiply first in this case. So here's my formula for the circumference. And then I do 50 times 6 pi. I leave it in terms of pi. So just 50 times 6, 5 times 6 is 30 with 0. And then I reduce this. 300 over 360. That reduces to 5 pi over 6. I think 30 goes into both of those. Okay? 5 pi over 6 inches. I leave it in terms of pi. unless it says to round. Then I would do 5 times pi divided by 6. Okay? It's very important to understand. Also, keep in mind, you could have reduced this first. You could have said this is 5 over 36 and then multiplied by 6 and then reduced it further. I don't care if you reduce here or reduce here. But remember what it means to reduce a fraction. What I did here, so I noticed that 30 goes into both them, but what if you said 10 goes into both them? I divide the top by 10, divide the bottom by 10, I get 30 over 36. Well, I know that 6 goes into both of those, or not 6. Yeah, 6 does. So I divide the top and the bottom by 6, and 30 divided by 6 is 5, 36 divided by 6 is 6, and then don't forget the pi, okay? Don't forget pi. Your answers are wrong without pi, and then our units are inches, okay? So that is what 11-1 circles and arcs is all about.